tomorrow when all of a sudden you see one of those on your test and you're like, oh my gosh, I hated that from the homework quiz. Okay, redo it anyway. I'm telling you one's going to be on there. Okay, so I'm expecting you guys to make these corrections right next to your homework last night. I'm doing it as a brand new part in my notes. Part of your learning and part of you understanding your mistakes is making the corrections next to the original work. So go back to the original work and make the corrections you need to there so you can see mistakes you may have made. All right, if you weren't asking questions, you are still taking a look at everything that we're doing. So you're looking at every problem that we're doing, you're paying attention. All right, so this is from page 223. Our first one is number 11. Who asked me for 11? Okay, so the directions were write all positive integers. All right, I'm sorry, all positive factors. So I needed to go through here and figure out all the factors. Well, I like to do factor pairs. I feel like it's easier. So I have 1 and 111. That's one set of pairs. Well, we know it's divisible by 3 because 1 plus 1 plus 1 is 3. So we know it's divisible by 3. So I have 111 divided by 3. That's going to 3 times 37. And I think that's it. That's all they were looking for. They say positive because technically this is -1 times a negative 111. And -3 times negative 37. So we have negative factors as well. Christiana, does that help you? Okay. The next one you guys asked for was 15. Who asked me for 15? Okay, yep. All right, so I have 28 plus the quantity of 1 plus 5 all squared times 4. This is simply an order of operations problem. All right, the first thing we do in order of operations is what? The first thing we do in order of operations is what? Addison? You do what's inside the parentheses, and here you can add 1 and 5. So I'm going to rewrite everything. By the way, pay attention to what I'm writing. I don't just want to see 1 plus 5 is 6 by itself somewhere. Every line is exactly the same as the line before it. We've just simplified something. The moment you start breaking stuff out is the moment you forget to put stuff back in, and the order in which it needs to go back in. All right, so inside the parentheses is 1 plus 5, which is 6, squared plus 4. What's my next operation that I have to be doing? Erin? Yep, I need to do my exponents. So I have to do 6 squared. So this is 28 plus 36 times 4. Now what? Mia? Multiplication. So off to the side, I'm going to do 36 times 4, which I believe is 144. Correct me if I got something wrong. All right, and then I'm going to add 28 to that. 12, carry the 1, that's 7, 172. And I hope that was our answer. Angela? Factors are not 7 and 8. No, they do. I don't understand. I'm not asking for you to state any rules. Well, no, that's not, like, I mean, like, if 7 or 8 is moved by the method, you have to put that in. I have not given you rules for 7 or 8. Is that what you're saying? Yeah, of course. If you had 56, you would have to write 7 and 8 as factors because they are factors. Those rules are only meant for you to have easy ways to figure out if a number is divisible by 3, or a number is divisible by 6, or if a number is divisible by 9. Like, Those are just rules to help you figure that out. That doesn't mean that any other factors we don't include because we didn't do a rule. You know what I mean? Is that what you're asking me? Okay. Okay, so if I said write the factors of 56, it would be 2 and 18, 28, 2 and 28. It would be 8 and 7, right? I mean, yeah, we'd have to include them. Okay. All right. That was 15. The next one we had was 18. Who asked me for 18? Okay, Michaela. All right, so 18 said evaluate the expression 7m squared minus 5 when m is equal to 3. Okay, you're all taking a look at this with us. What does it mean, evaluate the expression? What does it mean, evaluate the expression? Layla? Yeah, you put the number in through the variable and then simplify. So I'm just going to substitute in. Remember, always put the number you're substituting in parentheses, even if it's positive. All right, it kind of helps us make sure that we know what number is. So this is 7 times 3 squared minus 5. What do I have to do next? Come on, I need all of you helping me out here. This is your review. I want to make sure you're all thinking, what do I have to do next? Jack? I have to do the exponent. So that's 3 squared, which is 9. Dominic, now what? Excellent. What do I get? So I have 63 and then minus 5. That's plus a negative 5. If you want to write that, you don't have to. 63 minus 5 is 58. That should be 58. So is that, Michaela, does that help you? Excellent. Here's 19. Who asked me for 19? All right, so 19 was the quantity of 2a plus 1 all squared when a is equal to negative 4. What do I do? Mateo?
So you substitute the a with negative 4 and then rewrite it as in parentheses 2 times negative 4 plus 4 and all is for 7.
Excellent. Keep going.
You multiply in parentheses 2 negative 4, which is negative 8 plus 1 for the second, and then it's negative 8 plus 1 is negative 7, and then that's for the second.
Excellent job. If you noticed, I kept everything in parentheses. Why? Why did Mateo make sure that we kept everything in parentheses here? Jack? It would be. If I don't keep all that in parentheses, and I leave it as this, negative 7 squared without the parentheses around it, this is a negative 1 times 7 squared, which is negative 49. I need you to remember that. So the parentheses, when you have a negative base, the parentheses mean something. I guarantee you're going to have that on your test tomorrow, whether to have something in parentheses or not. All right, so that is 19. The next one we had was 40, I believe. So let's jump to 40. You're welcome, sweetheart. So if I take a look at 40, when you are simplifying fractions, you have to use the power rules if there are exponents. There's variables with exponents. You have to. All right, so for number 40, I'm just going to rewrite this because I am going to divide out common factors between my numbers. What common factors do I have between 25 and 5? Vincent? 5. So 5 becomes a 1. What does 25 become, Vincent? X. Excellent. All right, somebody take care of, so my numerator, I have a 5, and my denominator, I have a 1. Somebody use my division power rule dividing m to the first divided by m to the first. Someone do this for me. Kira? No. You're using your power rules. I want you using your power rules. Yes, you could do that, but I want you using your power rules. So m to the first divided by m to the first. What's my power rule for dividing? This is m to the first divided by m to the first. Simplify that. Somebody simplify this using my power rules. Angela. No, not plus. I'm dividing two numbers with the same base. I keep the base, and what do I do with the exponents when I'm dividing? You guys, you are absolutely having one of these where it's a little bit more complicated with numbers, many variables to simplify. So you have to know your power rules. I'm dividing two numbers with the same base. I keep the base. What do I do with the exponents? Romano? You subtract them. 1 minus 1. The numerator minus the denominator. So I end up with 5 times m to the 0 power. What is m to the 0 power? Jack? No, it is not 0. What is m to the 0 power, Audrey? 1. So that is a 1. Somehow you've got to show me that m to the 0 power is 1. So my final answer is 5. You are absolutely having one of these on your test. So if the power rule stuff throws you, you have to go back and figure out what you're doing with those power rules. All right, so that was 40. Let's take a look at 41. Who asked me for 41? Okay, so I have 2 times y over 8 times y. By the way, mine are going to be harder than this. All right, again, I'm going to use my division. Well, I can divide out common factors between the 2 and the 8. They both have a common factor of 2. The 2 becomes a 1, the 8 becomes a 4. So right now in my numerator, I have a 1. In my denominator, I have a 4. Just like I did up top, I'm dividing two numbers with the same base. I keep the base in the numerator, and I subtract the exponents. So in my numerator, I have y to the 1 minus 1. Which means I have y to the 0 over 4. Well, y to the 0 power is 1, so this is simply 1/4. All right, I'm not doing 42. 42 is exactly like 40 and 41. I am going to do 43, so let's take a look at 43. 43 said I have 9x to the second divided by 27x. This is more like what you're going to have. All right, so I'm just going to rewrite this so I can show dividing out common factors with those numbers. 9 divides into itself once. 9 divides into 27 3 times. So right now I have a 1 in the numerator. I have a 3 in the denominator. Do not separate off to the side somewhere your work with those variables and then bring it back. I will not take that, because you're going to forget where to put it. All of your work needs to stay together, just like I'm showing you here. So I'm dividing two numbers with the same base. I keep one of my bases in the numerator. What do I do with the exponents? I keep one of my bases in the numerator. What do I do with my exponents? Mateo? What am I subtracting? Tell me exactly what I'm doing. Excellent. 2 minus 1. Your numerator exponent minus your denominator exponent. So I end up with 1 x to the first over 3, or just x over 3. I'll take either one of those. Who asked me for 43? All right, well, there's one for all of you. All right, let's take a look at 45. 45 is just one of those ones where you've got to keep track of what you're doing. You've got to keep track of being organized. All right, if we take a look at 45. God bless you. All right, 45 tells us that we have 1, 2, 3, 4 people. All right, we want to know they're going to be in 4 desks. Each day, a different arrangement of seating. How many days before they start repeating. All right. So I'm not going to take the time to do this entire thing. But what you need to do, the key to these is staying organized. What things do I need to keep track of here? I have 4 desks. We want to know each day they're sitting in a different arrangement in the desks. We want to know how many days before they are going to repeat. What things do I need to keep track of? Erin? All right, so I have my number of days. What else do I need to keep track of other than my number of days? What else do I need to keep track of? Alex? Yeah, the seating arrangements. All right, so now I've set up what I need to keep track of. All right, so now I'm just going to keep track of it. So I'm going to say, I'm just going to use first letters. I have M, D, T, R. All right, my second day, I'm just going to shift it. D, T, R, M. My third day, and I'm just going to shift this again, and I'm making sure that I keep these desks. The first is a first desk, second, third, that it's very organized, and I'm going to keep going with that. Then what I'll do once I go through this one, so the 4th day is going to be R in the first seat, M, D, T. Now I'm just going to completely switch up the arrangement. All right, and you've got to figure out how many possible arrangements we have. Now, once you start to see a pattern happening, if you see a pattern happening, you can kind of state what the pattern is and move on from there. All right, and you can say, okay, the pattern is, every 4 days this is going to happen, or and we can come up with how many days it would be. But this is the organization that you need to keep, so you can see what your arrangements are and who's sitting in what seat. All right? All right, let's move on to 51. All right, 51 said, evaluate the expression A plus B divided by 4B when A is equal to -5 and B is equal to -2. Who asked me for this? All right, so Arana, what does it mean that I'm evaluating it? Absolutely, just put the numbers in for the variables. So A is a -5 plus B is -2 divided by 4 times -2. So when I finish simplifying this, -5 plus -2 is a -7 over 4 times -2 is a -8. So this is a negative divided by a negative is a positive. So this is just simply a positive 7/8. Does that help you? Awesome. All right, let's take a look at 52. You guys, I'm moving along so I can get to everything. If you need to stop me for anything, please do. All right, 52 is something similar. I have B minus A divided by A minus B. This is one in which you need to make sure you're paying attention to the signs. Yes? Yep. That's when they're exponents. So Frankie, this is just a fraction. If I had something like this, x to the -7th over y to the 3rd. My exponent is negative. I can't have a negative exponent. This is simply just a fraction. These are not exponents. What's a negative divided by a negative? Isn't just a negative divided by a negative a positive? You know what I mean? Yeah, it is. It will. Once we introduce these negative power rules and stuff, it does get confusing because you're like, oh, a negative number, and you have in your head, oh, I need to move it to its opposite location to make it positive. Those are just exponents. So when I just have a fraction, a negative numerator divided by a negative denominator, this is the same thing, Frank. If you want to see it this way, this is like negative 1 times 7 over negative 8 times 8, and I can divide out that common factor of a negative 1. Does that make sense? Or you simply remember a negative divided by a negative is a positive. Okay? I'm glad you're asking. That's awesome. All right. Who asked me for 52? Aaron, sit up. Who asked me for 52? Okay. So, Angela, what do I do? These are my values right here. What am I going to do? So I have negative 2 minus. And if you notice, Angela, I put the negative 5 in parentheses. Okay, and then put in for my numerator, or denominator. Well, no, because it was minus. Minus negative 2. All right, and I do like that you did adding the opposite on those. That was super smart. I do agree with that. Once we do adding the opposite, now we can see we have negative 2 plus a positive 5, which is a positive 3. Negative 5 plus a positive 2 is a negative 3. Well, 3 divided by negative 3 is going to give me a negative 1, because a negative divided by a positive or a positive divided by a negative is a negative. Okay? All right, so that was 52. 59. Who asked me for 59? All right, Christiana, let's take a look at 59. A problem like 61, which we're going to be doing next, is like what you're going to have. So I would put a big fat star around 61, or at 61. So 59 said, I have 4 to the 8th divided by 4 squared. Now, I want to compare this to something. Well, here, I'm just going to write it. I want to compare this to something. All of you take a look at this. If I had 3x squared divided by 3x, I just want to take a look at the numbers. Can I just divide out common factors between the 3's here? Can't I just say 3 divided by 3 is 1, 3 divided by 3 is 1? Can't I do that? How many of you guys think I can do that? How many of you guys think I can't do that? Why can't I do that? When it's the numbers, why can't I do that? Jack? Talk louder. I can't multiply the 3 and the x. Let me ask you this. If I had this, 27y to the 5th divided by 9y. Simplifying the numbers, can't I just divide out common factors? How many of you guys agree that I can just divide out common factors between the 27 and the 9? The 9 becomes a 1, the 27 becomes a 3. Why can't I do the same thing on those 3's? Layla? They don't have exponents. Well, they do. What are the exponents on my 3's here? So this is 3 times x squared. This is 3 times x. What is my exponent on this 3? This is a 1. What is my exponent on this 3? Okay, well, let me ask you something. On this other one that I did, I had 27y to the 5th, 9y. What's the exponent on my 27? 1. What's the exponent on my 9? So when my exponents on my numbers are 1s, can't I just divide out common factors? How many of you guys agree that I can do that? Are you guys okay with that? Okay. However, when I look at this one, put your feet down, sit up to your desk. What are the exponents on my 4's here? Kira? 8 and 2. Can I divide out common factors between those 4's and make them 1s? No. It's only when the exponents on the numbers are 1s that I can just simply divide out common factors. Here I have to use my power rules, Because the power rules are dividing out the common factors. Because there are 8 4s in the numerator. There are 2 4s in the denominator. All right, here there's only 1 3. And only 1 3 in the denominator. So here I need to divide out, I need to do my power rules to divide out common factors. So I have in my numerator 4 to the 8 minus 2, and that's all over 1. So this is going to be 4 to the 6th power. And then I would multiply that out. If I gave you one like that, your power would be like to the 2nd or the 3rd. I'm not going to go any higher than that because that's going to take you too long. Who asked me for 59? Are you good with that, Christiana? Oh, okay. All right, if I take a look at 61. 61 said I have 28xy to the 7th over 32xy to the 12th. This is more like what you're going to get on your test, is this. All right, so I'm just going to rewrite this so I can show dividing out common factors between the numbers. The numbers part of that. All right, well, 28 and 32 have a common factor of 4. The 28 becomes a 7. The 32 becomes an 8. So in my numerator, I have a 7. In my denominator, I have an 8. Now with my exponents, or with my variables, I'm going to use my power rules. X to the first divided by x to the first is x to the 1 minus 1. Somebody do my y variable for me. I keep my y in the numerator. I'm dividing two numbers with the same base. I keep the variable or the base in the numerator. What do I do with my exponents? Vincent, tell me what I'm subtracting. So 7 minus 12, correct? Yep. Your numerator minus your denominator exponents, not the bigger minus the smaller. If you have a question, ask me. Do you have a question? This is number 61. All right, so I have 7 in my numerator. X to the 1 minus 1 is x to the 0. And that's y to the negative 5th, all over 8. All right, what is x to the 0 power? Maya or Mia? That's a 1. So I'm going to cross it out and just put a 1 there. All right, can I leave a negative power? So this goes back to the negative power rules. Can I leave a negative power, Alex? No. So, Frankie, this is when we go back to moving it because the power or the exponent is negative. Alex, what do I do to make a positive exponent? Excellent. So my 7 stays in my numerator, right? Why does my 7 stay in my numerator? Alex, why does the 7 stay in the numerator? What's the power on my 7? A 1. So the power, the exponent on my 7 is a positive 1, so it stays where it is. My y to the negative 5th has to be moved to the denominator because it has the negative power. What is the power on my 8? What's the power on my 8? Audrey? On the 8. It does have one. Michaela? It's a 1. That's a positive 1, so it stays where it is. And that is my final answer. So you only move the base with the negative exponent. Any base with a positive exponent, you leave where it is. All right, so that is 61. All right, so let me give you guys, at the very end of your homework, you're writing extra examples there. So the very end of your chapter review, you're writing extra examples. All right, so let's do some negative power rules. So I want you guys to simplify. 49 w to the 3rd z to the 2nd divided by 14 w z to the 6th. All of you simplify that, please. You have to use your power rules. Do not write this out in expanded form. Go ahead. When you're done, check with someone sitting next to you. Is there a common factor I can divide out between the 49 and the 14? Addison? 7. So what does my 49 become? And what does the 14 become? All right, so in my numerator I have a 7, my denominator I have a 2. All right, Addison, do my W's for me. Yep. Excellent, and both of those in the numerator, right? You guys, everyone take a look at your work. Take a look at my work. This is what yours should look like. You're not separating, ladies. You're not separating anything apart. You're keeping everything together. This is what I'm looking for. All right, Addison, so I have 7W to the... 3 minus 1. 2? Just to the second. And then Z to the, what's 2 minus 6? Or 2 plus a negative 6? Negative 4. All over 2. Right? Vincent, or Dominic, you're paying attention. All right. Am I done, Addison? Why? That's exactly right. So what am I going to do with that Z to the negative 4th? Excellent. So I have 7W squared over 2Z to the positive 4th. God bless you. How many of you guys got that? Awesome. All right. So that took care of our negative exponent rule and our division power rule. All right. You guys asked me for, let's do the area one, and then I'll do scientific notation real quick. So let's say I have a rectangle that looks like this. My width is, let's say, 2W squared, and my length is 3W to the 3rd plus 1. All right, and I want to write an area equation, or find the area. Well, the area of a rectangle is length times width. God bless you. What is the length of my rectangle? And length and width, it doesn't matter which is which. So what's the length of my rectangle? Mateo? Yep. I have to put that entire thing in parentheses. Because that entire dimension, that entire expression is the length. Times my width of 2W squared. What property do I now have to use to do this multiplication? Christiana? I do. I have to do the distributive property. So that's going to be 2W squared times 3W to the 3rd plus 2W squared times 1. Now I'm just going to simplify each side of that addition symbol using my power rules. Let's do that first part. Well, I'm going to move the 3 and the 2 next to each other, the 3 and the 2 next to each other, and my W's next to each other. Now I'm going to do the multiplication. Well, 2 times 3 is 6. I multiply in two numbers with the same base. I keep the base, and what do I do with the exponents? Mia, you add them. W to the 2 plus 3. So this is going to be 6W to the 5th. And now for the other term, I'm just going to multiply 2W squared plus times 1 which is simply 2w squared. I am done. There is my area equation. I cannot add those. Why can't I add those? Frankie? Because they're unlike terms. One has the w to the fifth, the other has a w squared. You're absolutely getting one of those. So I would highly recommend you practice that again. All right, you guys asked for proper scientific notation. This is the last thing I'll do. Who needs to see what's up there? All right, quickly get that written down because I have one more to go. All right, so let's take a look at proper scientific notation. Remember, for a number to be in proper scientific notation, the first factor has to have only one digit in front of the decimal. So if I have something like 0.036 times 10 to the fifth power, I need to write this in proper scientific notation. By the way, when I give you numbers in scientific notation at your test, you may not change them into standard form. They have to be kept in scientific notation. All right, so I need to change that first factor into scientific notation. So I have 0.036. Where does the decimal have to go? Jack? Between the 3 and the 6, so it's going to go here. So I move my decimal 2 places. So now I have 3.6 times 10 squared. My standard form was really small. I changed 0.036 into a scientific notation. It was a really small number that I started with. What is the sign of my exponent then? Frankie? Negative. All right, and then I'm going to bring that times 10 to the fifth that it was originally with that number down with it. And now I'm just going to multiply my powers, my 10 to the powers. So I have 3.6 times 10 to the negative 2 plus 5, which is 3.6 times 10 to the third power. Questions on this process? All right, you guys cool? All right, you guys can go. Make sure you have your chapter reviews with you tomorrow. I'll be checking them in.